Hi everyone, welcome to today's webinar on low volume road design using our RoadEng civil engineer software. I'm your host for today's webinar, Andy Moon, and with me is one of our applications engineers, Jack Rymack. Oops, sorry. Okay, so before we get started, some standard housekeeping. Please don't be afraid to ask questions. You are encouraged to engage with us through the through the GoToWebinar panel, and watch for an email sometime after the webinar with the link to the recording. Okay, so today we'll be demonstrating a realignment of a 2-lane rural paved road based on total station data. Jack will be demoing in 5 major steps. So first, we'll import some survey data to create a tin model and some contours. We'll be using total station for this demonstration, but just to let you know, RoadEng also works with many other survey methods, including LiDAR and drone data. Second, we'll set up our cross-section geometry in the template editor. Next, we'll draw some horizontal and vertical alignments. Then we'll quickly demonstrate how to minimize earthworks costs and automatically balance your mass hull through our optimization technology. And then we'll also show the addition of a cross-section culvert using the culvert editor panel. Finally, for output, we'll show our built-in multiply report builder as well as a couple of other export and output options. Okay, so now to quickly introduce RoadEng for those of you who have not used it before. It's basically an easy-to-use road and site design software, and most of our users have not required formal training, and the learning curve is it's been quite smooth. It's only days or weeks compared to years with some other civil design software. As we'll show you today, you'll be able to design from start to finish, from the survey data to the output sheets. The program itself is modular, and today we'll be using 2 modules, terrain and location module. So terrain module is our module for working with survey data. And this is an example of a tin model that we created as well as contouring and for site design. And location module is specifically designed for corridor designs. It has a unique window setup that allows you to have real-time interactivity as you design your alignments. As Jack's going to show you right now, when you make changes in one window, it's updated in real time in all the others. And without further ado, I'll pass it over to Jack, and let's get into the software.
Thank you very much, Andy. As Andy said, my name is Jack, and I'll be your presenter here today. Just want to show my screen. Let's start going. Okay, I'm going to spend probably about half an hour to 45 minutes with you guys, showing you the software. Import some data, some total station data, as Andy said. I've got an import specification for a total station file. Open up that data. So it's based on codes. Here's all the codes. Some of them are connected into line work. Some of them have not. Like there's some codes for tove slope right and other codes that are in there that have been connected. There's a centerline code that's been connected. Let's just connect it. Let's just open up the data. If you guys have questions, don't hesitate to ask in our panel, as Andy said. Import that data. Here we go. This is an imperial file, so for our Canadian and non-US viewers, we can work in metric. Just be aware that this is an imperial file. and I will be using yards and feet, and instead of centimeters and meters and cubic meters. So just be aware of that. Tin and contour our data. Change my view first to something a little bit more reasonable. 1200 scale is good enough. Generate terrain model. I'm going to do minor contours of 1 foot interval, major contours of 5 foot interval. And I'm going to change my triangle length to around 300 feet. So no triangles will be created that are longer than 300 feet. That way I can get all of the points connected that I need. And I'll be creating contours. Let's just do it. There we go. You can see contours there. All right, just a little recap of what I've done so far. Import data, contour the data. Next step is what I'm going to do is I'm going to take this over to the design module, do some horizontal alignment, and do some vertical alignment, and then I'll give you some more steps later on. Save my data as County Road, April 4th. Go to my location design module, which is the corridor design module or road design module. Open up a new terrain. Browse for that terrain. Open up this file. And I'm going to start on that current point that I selected on the file as a starting point, which is down here at the start of the road. Change my screen layout. To a horizontal alignment screen layout. Make my background a little bit more vibrant so you can see it a little bit better. Less washout, zero washout, just so we can see the background a little bit more. There. I'm going to start my alignment now. Oh, before I do alignment, I'm going to get a set of templates that are more appropriate to a county road. I'm going to use a county road with a subcut, just to show you guys how to do that kind of stuff. So it's going to be a subcut template. So that's what it's going to look like. If you raise the template above ground, the subcut will disappear. This is a realignment, so we need a subcut so that we can get some of that material that we're going to use in building the road. Just a little bit about templates before I go on. Every template is made up of a number of components. Here we have a left and right road, a left and right ditch, and a left and right cut dull slope, and also subcut component. This one has 6 components. To change the properties of each component, you just double click on the component and you can change the properties. You can change the thickness of the asphalt, the width of the asphalt, the width of the shoulder, the slope of the shoulder, a whole bunch of different parameters. Let me leave it at that. I'm just going to apply that template. Press OK. I am going to do one more thing before I continue on with design. I'm going to widen out my surface a little bit more. You can do that in here just in case my surface falls off the edge over here. I can do that in here, just widen it out a little bit more, just create more surface. I have a question here. I'm just going to go through the question. I'm just going to read it first. The question is, are the templates being shown today available immediately with the program, or do users have to develop their own templates? They are available to you with the program, and if you guys have some more complex templates, we can always help you create those templates. That's just the way we work. So yes, the answer to that question is yes. I'm just going to bring my continue my alignment, put an IP all the way up here, move that IP around a little bit more, make it a little bit higher. And then I'm going to add one more alignment IP over here. That's where I'm going to stop. I'm not going to go right to the end of the road. Just snap to that center line point. Jump back 2 IPs. This one is going to be a, let me just go in here for a sec. This one's going to be a 40 mile per hour design right here. This particular curve, circular, 40 mile per hour, which will give me a 600-foot radius. 6% super automatically comes in with AASHTO tables. By the way, for our friends that are in Canada, we do have TAC tables built into the software. These are AASHTO tables that I'm using here because it is an imperial design. Let's apply that curve. There we go. Can move that alignment back a little bit more. You can see everything updates real time as I move it around. I think I'll move it forward, back to the center of the, following that original alignment as much as possible. Set that as my default curve. Jump forward, get my default curve, apply. You can do spiral curves too, but I think most people doing 2-lane county roads, designing 2-lane county roads, whether they're paved or gravel, do not use spirals. They use circular curves. I'm going to actually design this one so it's a little bit higher, 50 miles per hour, and that's going to give me a 900-foot radius curve. Okay, so far, just to recap, I've imported the data, contoured the data, and done some horizontal alignment. Now we're on to vertical alignment. Get a screen layout for vertical alignment. I have another question here. Can you show an example of the interpolation function? Okay, interpolating between, are you talking about interpolating between, so that it gives me a grade or a grade percent or a slope between the two? I guess, yeah. It's already set to interpolate between 2 points. Let me just go back. So if you have already set that, if you turn on auto, it will automatically interpolate between the 2 points. So right now this design speed is 50 and 900 foot radius. It will interpolate between, it will give me a transition length of 225. Let me just turn this back on. Could I answer that question after? Point elevations. Okay, I am still a little confused about what the question is. Let me continue on and I'll think about it a little bit more and I'll come back. I'm going to go on to vertical design now. Profile alignment. Different screen layout. Get a screen for, you can see here there's a whole bunch of things happening. There's a data window with cut, fill, and mass haul. And also a mass haul window that has endless cut. So red is endless cut. Let's just see what the other colors are. Free haul is green. Overhaul is yellow. You can set your free haul and your overhaul distance. For imperial designs, you want to set your overhaul and free haul to a fairly high number. For metric designs, probably going to be much lower, usually about 100 to 50 to 100 for overhaul or free haul, and then maybe about 300 to 500 for free haul in metric designs. And borrow is blue, and waste is red. As you can see, we've got endless amount of waste. All right. Left click once. You get a grade automatically attached to the alignment. Left click. Try to get as much of this rid of this borrow as I can. This waste as I can. Now I got some borrow going on. Pull that down. Move that alignment all the way up here. Come back down to this side of the slope. Got a little bit too much borrow again, so I'm going to pull down to create less borrow, more cut. You can see I'm starting to get balanced a little bit better. Move this alignment point down a little bit more. Try to get rid of some of that borrow. Attach to the end of this point right here, and then put in an IP in the middle. Get rid of some of that borrow. There. Pretty well balanced, except we got about 171 cubic yards of waste by the end of the design. Let me put in my vertical curves. I'm going to use 50 mile per hour curves. Sorry, not going to use 40 mile per hour curves. Set that as my default. Jump forward. Get my default. Apply. Jump forward. Get my default. Apply. Get my default. Apply. Okay, that's vertical alignment in a nutshell. I am going to proceed on to a optimization software that will optimize this alignment. Right now it's not fully balanced. There's still a lot of earth being moved. There's a lot of overhaul that I don't like. I'd like to balance this as much as possible. Let me go into the alignment panel and optimize this road for you. It's a new technology that we're very happy with. It will give you the lowest cost vertical alignment. Change my standards. This is going to be a 55. For a 40-kilometer design road, you need to put in the sagging crest to 55. I'm going to 100-foot tangents and 100-foot curves. Don't forget to press the Add Edit button. I'm going to put a control point at the start of the alignment so it doesn't move up and down. And also put another control point at the end of the alignment so it doesn't move up and down. I'm not going to worry about pits. The way that the software calculates the lowest cost vertical alignment is the user has to figure out what their cut costs, their fill costs, their hauling costs, and their loading costs are going to be. And for all the different ground types. I'm just going to leave it at that and then process. Right now, the road is going to cost around $273,000 to build. Hopefully, we can do better than that. Usually, we have anywhere from 5 to 30% savings in costs. Let's see what it comes up with. So it has to go through a few more calculations before it figures out. Yes, the question is, will Softtree accept horizons for topsoil, depth, rock, etc.? Yes, it will. Okay, the software is not going through the final calculations. It's going to calculate a balanced alignment. At some point, an optimality gap will appear. That optimality gap will tell me, in the worst case scenario, how far we are away from optimal. It should be pretty low. And then at some point it will stop and give me a 0. I'm not going to wait for it to stop, but we'll see what it gives me as the starting number, and I might decide to stop there. There, it's got a 1.33%. So at most, we're 1.33% away from optimal, and we dropped the cost down quite a bit to $114,000 from $273,000. Let me just cancel this and press yes, and then it will calculate the last part of the alignment. We do have the balance profile, and the lowest cost alignment was found. and I'm going to set that as my current alignment. It's quite different than the other alignment. You can see that it's better balanced. It's actually crossing the zero line a lot more. It's a nice piece of road, nice balanced design, quite happy with it. The question is, can we grade ditches independently of the center line? Yes. That was beyond this demonstration, but we can definitely show that to you independently later on. Another question is, can the optimization be done only on the vertical alignment or both vertical and horizontal? Right now we can only do vertical, but we are working on horizontal, and we should have that. No promises. We don't know. I'm not privy to when that will be coming out, but we should have that sometime soon, hopefully. It's, I think, in beta testing pretty soon. So yeah, we will have a horizontal optimizer at some point, if that helps your answer. Right now we only have vertical optimization. I would like to do one more thing before I do an output sheet. So just a little recap of what I've done so far. I've done import, I've done horizontal alignment, I've talked about templates, I've done vertical alignment, I've done vertical optimization. Now I'm going to show you how to put in a culvert, and then I'll go into output sheets. I would like to possibly I'm just going to choose a location where I want to put a culvert, probably somewhere around this low point here, or maybe even better over here. Let me just see if I can raise the alignment up a bit more. Get a nice low point here. Let's take a look at the cross section. Raise it up a bit more. Okay, let's put in a culvert right here, culvert editor, which is down here. Add a cross train at this location, station 2340. Automatically puts in the station that I'm at, and I just happen to be at a round number. And I'm going to put in a 12-inch pipe that will auto length, and it will attach to upper ditch catch point, and change the pipe size here if you want to whatever size. I got a 12-inch pipe in there, and apply. Let's just see if it's attached to the upper ditch catch points. Yes, it is. So it's attached to the bottom of the ditch, and it goes down a certain grade till it hits the fill on the other side. All right, I've done culverts. Now let's go on to output, and then first of all, I'll do a quick drive-through, show you what the road looks like as driving through it in here. Open up a 3D window, get rid of all these panels. Open up a 3D window. Go to my 3D tab, drive-through flyby, play. Increase the rate. I could go one step further and merge the road into the terrain, but I'm not going to do that for this demonstration. I don't want to spend too much time doing this kind of stuff. I will go on to output sheets now. Show you how to create a plan profile sheet, cross-section sheets. Okay, there's another question I see here. Can I put an expansion and compaction factor in? Yes, you can, right here, under ground types. You can put that right here. So if it's going to be a swell factor, you keep the cut the same at 1 cubic meter or cubic yard, and what does it shrink or swell to? If it's going to be shrinking, that means that it's going to be, you're going to have a number larger in here than the cut side. If it's swelling like rock, then you're going to have a number here smaller than the cut side. Let's go on to output sheets. I've got my multi-plot report builder, and everything in the report builder is based on books and chapters and pages. Let me just see if I can open up an existing book layout. Let me just open up this one. I'm going to reposition this so that sections are after the plan profile. So I'm going to right click, move down. So the chapter will be, the first chapter will be plan profile sheets, plan over profile sheets, and the section chapter will be section sheets. I am actually going to delete the, just so I have more room for my sections. I'm going to delete all this. And expand my cross sections. Unlock them first because these have been locked. Expand my cross sections so that they fill up the whole page. Change my scale to 240 and 240. So keep in mind that you should be working at the chapter level all the time. You shouldn't be working at the page level because things will happen that you don't want to happen. If you start moving things around, you'll get some strange behaviors. So work at the chapter level all the time, please. I've got volumes in this chapter. In this chapter also, I've got a legend. You can create, I've got a horizontal curve panel. I am going to go to my pagination and set up my pagination to maybe something a little bit more than 500 foot. I'm going to change it to 1,000 foot, get less pages. Fade out my background a little bit more because I'd like to see the road a little bit better. Wash out my background a little bit more, maybe back up to 50% washout. Show you how to put in some labels for stationing. The question is, can you display specific cross sections based on your stations? Yes. Another question is, do the drains, retaining wall, and other roadside elements display in plan view? Yes. Yes. So you can actually display the actual drains widening. You can display those things in plan view and profile view, but they're not really that great in profile view because they're the same elevation as the drains on the other side normally. Okay, let's just put in some stations here. Double click on this, labels plus sign. Go down here, user defined labels. I like my labels to be pretty large, and I like them to be red for stationing. Options, add attribute, L station, display attribute description, point selection. I want 100-foot labels, so I'm going to select all and turn it off, and then go back up here and just turn on 100-foot. We have two preset intervals, but you can change those to whatever you want, 100-foot or 50-foot or 1,000-foot if you want to. I've got 20 and 100. I'm going to just choose 100. And press OK. And OK. And my user-defined labels is on. That's good. And press OK. There they are. Let's do the same thing in the profile. Labels plus sign. Go down to user-defined. You have 4 slots, by the way, for user-defined labels. You can put in different types of labels, different categories of labels. Let me just change that to 16 also. Change it to red. Options. Turn display attribute description. All that's saying is turn off L station equals. So it won't say L station equals. It will just give the number. Add my attribute. L station. Make sure that that's on. Yes, it is. And make sure that I've got point selection turned on. I want 100-foot again. So I turn that off. Turn that on. And finally turn that on. There's my, if you want a line connecting those, you can easily turn that on also. I don't think I have that line turned on. Position. Connector for the leader. There should be a line there. I don't know why it's not showing up. Let me just see what's going on. Okay, so I'm going to go to page 1, page 2, sections. Okay, I had a question here about question is, can you show field entrances or driveways in the plan view? Yes, you can. That's just a little bit out of the scope of this. Yes, you can. That's a little bit out of the scope of this demonstration. I'm getting close to my end of demonstration time. I would like to, from my part, I would like to thank you folks. I think Andy would like to say a few final words. I'm going to change presenter back to Andy. Are you there, Andy?
Yes, thank you, Jack. Okay, well, thank you everyone for joining us for today's webinar. And just to let you know, we do have upcoming webinars scheduled on horizon. Cable planning and design for April 25th, and RoadEng 9, the version 9 of RoadEng preview scheduled for May the 16th. Yeah, so that's about it for today's webinar, and thank you everyone once again for joining today's webinar on building low volume highways.